Okay, so what you're looking at are the exact, so this graph you're looking at is the exact same graph as the last image, same point. So this point right here is 3, 5. This point right here is 11, 5. This point right here was 7, -1. And the same points exist over here, right? So 3, 5, 11, 5, and 7, -1. Right? This would also be -1, -1. Same here. So we're going to, on the last slide, we wrote the cosine function, which was, pretty basic. We made this our starting point for each. We graphed a positive cosine function, and I believe what we ended up with was, the format that I used was A equals +3 times cosine of pi over 4 times quantity x minus 3 plus our line of oscillation, which was 2. Okay. Plus 2. Okay. So this purple dotted line is your line of oscillation. That's 2. Remember, we get that by averaging the maximum and minimum point, and then the measurement from a high point to the line of oscillation is your amplitude, which is 3. We chose for the cosine model to start here, and if you remember, cosine starts at a high point and runs down like this, right? So this is the point we want to focus on, this far left point. So that's what we define as h. Sine function, on the other hand, again, remember from the last image and the other sine graph, starts in the line of oscillation and runs like this. So I'm looking for this type of point on this curve here, right? All the information still exists, right? So in this particular example, my period is still 8. My line of oscillation is still 2. My amplitude is still 3. So what I want to do is, I always like to have the line of oscillation visible for us, and I'm focusing right on this point right here. So this point, horizontally speaking, is 1. Okay. It's hard to see it on my screen, but on your screen, you should be able to see the grids. That point is an x value or an input value of 1, and that's similar to this point right here, right? So it kind of runs up, it's a high point, comes back down. So you just want to be able to recognize the sine function cycle on this graph, and we did here. So this is what I want to do. I want to start my sine graph here, right? So I'm going to make my h value 1. That's where my sine cycle is going to start, and that's my horizontal shift to the right. Everything else kind of stays the same at this point. So then I can write my equation down with all the information I have. I equals same amplitude 3 times the sine of angular frequency was pi over 4 times quantity x minus 1, and then plus my line of oscillation of 2. Okay. That makes the most sense to me. Now, just to kind of show you that I did reference a few times that there's an infinite set of these equations we could write. Let's say instead of starting here at this point, I chose to start at that point. I noticed that point right there is 5. Right? That horizontal measurement is 5. So my cycle here will kind of start this way, come up, and come back down. Right, that green cycle. So this point would be my starting point now, right? And I'm just going to adjust, my horizontal translation for the first one was 1. It's just going to adjust that on my equation. So if I wanted to write this equation, it would be y equals same amplitude 3, right? But the a value is slightly different. I should have put that out ahead of time. This green cycle doesn't start at a high point and move up, right? It starts at the line of oscillation and moves down, right? So the standard sine function starts at an oscillation. I said high point earlier, sorry. Starts at the line of oscillation and goes up. This green section starts at the line of oscillation and goes down, which means your A value is negative. So your H value to start is 5, which also pushes your A to become a -3. Amplitude is still true, the A value is -3. So then it's y equals -3 times the sign of pi over 4. That stays the same. X minus 5, and then plus 2. Right? So what shifted here is my A value is now -3 instead of 3, and my starting value of H is 5 instead of 1 in that case. And this can happen with the cosine function as well. We don't have to start at this high point here. We could choose to start down there at that low point and write the exact same function. So this is right. This is a this input right here is -1, and it starts here. It runs this way, right? So that's an inverted cosine function, which would make your A value. Right? If we chose to start here at x is -1, that's going to make our A value -3, then we can write this equation, y equals -3 cosine of pi over 4 times quantity x minus h, so that would be minus -1, which would make it +1, pleasure group, +2 for the line of oscillation. This is another version. We could do this over and over again, depending on where we choose our h value to start and whether the graph is in the standard position or kind of reflected when A is negative. That is, just another set of examples of how to write these functions.